Hello, it's Mike from Lux. What the heck is that? So what's interesting about this is that it is what looks like a cylindrical stalk in the middle here, and you have these branches that come out. And the interesting thing about these branches is they each have five. Oh, this one's missing one here. I'll fix that for you right now. The one on the bottom is missing. Okay, now they're all five. So every one, if you look on the side here, each one of these has five. This green section has five of the number 7 axles. 5 again of the number 7 axles. Again, this green one, 5, 5, and 5. But every time we have a new row, these axles shift over halfway between the next row up. Now that's interesting, okay? It's interesting because there's a thing called similitude, where in engineering you want something to match something else. Lux matches or similitudinous with nature, because if you look at a pine tree, right, a regular pine tree, you'll see that the branches have rows, and the tree will actually literally spiral up. So the next set of 5 or 10 branches that come off of the section of the tree will have rotated over, so that branch is between the last row of branches. And of course the benefit of that would be sunlight can now hit this branch here, right, and then it'll go past this branch and hit this branch here, and then go past and hit this branch here. So the most sunlight can go through the tree and hit all the branches, instead of the branches all being lined up in the same row, so they cast a shadow on the other branches and on their leaves, and the photosynthesis is reduced, okay? So this is a natural thing that happens in plants of all different sizes, of all different species. It's not just pine trees, okay? It's a really beautiful phenomenon in nature. So why does that phenomenon happen with Lux? What's going on with Lux? It's like nature. Well, let's take some of these sticks out and show you what is going on with this tree-like thing. So here it is. I took off a couple rows. Look at that. This is called, and we mentioned it before when we talked about prisms, these are anti-prisms. Okay? If this was the prism here, let's look at a prism. We have a prism here, and it's a prism, it's a pentagonal prism. And this is kind of like a pentagonal prism because this is also pentagonal. It's 5 trigons linked together. Okay? It makes kind of a prismatic space. The difference is it's been linked together not with squares, but with trigons or triangles, okay? And so what happens here is this. We have this beautiful thing when we put together how many are here. Let's count them, 1, 2, 3. Let's see, okay, this is a pentagonal one. So it actually takes 10 to make a pentagon, because you have 5 on the top and then 5 on the bottom. And they're offset. Do you see how they're offset? One here and one here, but there's the one in the middle here that's in between. So it makes a pentagon up here and a pentagon down there, but they're all shifted over. Okay, they're shifted over from themselves. That is an antiprism, and as in distinction to a prism. Makes a pentagon, or makes a trapezoid. Makes a pentagon, or will make a trapezoid. But the big difference is this pentagon here is the same pretty much as the pentagon on its other side. Whatever happens here happens on the other side. Here, no matter what happens on one side, it's all shifted over one on the other side. So that's the beautiful thing about antiprisms, is that they're shifted over one. They kind of gyro over. It's a word we hear a lot is gyro, because they're spinning around. And also, they create a whole family of antiprisms, just like there's a whole family of prisms. So we can have a prism, antiprism that's a hexagon, okay? And so this is a hexagonal antiprism. And we can make a stalk just like the other stalk that's made with hexagonal antiprisms. And you can see how I put these together. Essentially what I had here was a row of trigons. And I have 12 trigons here, because it's always going to be an even number if you want to come together. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because the bottom one here, the one that's pointed up, is going to match with the one that's pointed down over here. And you're going to bring them around, and you're going to snap them together, and it's going to make your little beautiful antiprism. Now, I know antiprism sounds like antimatter, which is a word you heard a lot in Star Trek and shows like that, because it sounds kind of science fiction-y and powerful. But it is kind of science fiction-y and powerful, but it's real science. This is a real thing. It's called the antiprism. And the more you know about the antiprism and the prism, the more you really know about the universe. When you look at coral and microscopic pictures of sea life, you're going to see these little antiprisms everywhere. You're going to say, wow, I know what that's called, I know what that is, and you're going to be connected to the universe in a really cool way. So that's antiprisms. You'll be hearing a lot about that in Lux when you build things, and I'll talk to you next time. This is Mike from luxblox.com.